did not start. We were supposed to do that time and distance. Speed, time, distance. Right? There's the chapter. First of all, I told you there also in force. What is motion? What is motion?
Motion.
A body changes position. A body changes its position with respect to time. That means now if the body is here, supposing this body is here, and supposing this body is here, and there is a straight path. So after 1 second, the body should be here. Position change. Position will change. Again, after say 2 seconds, the body should be here. So the position of the body should change with time. This is maybe at, if this is the position at 11 a.m. This is the position at 11:05 a.m. This is the position at say 11:15 a.m. With time, the body will change its position. Then it is motion. And if it is at rest, the body will be in the same position. 11 a.m. same position, 11:05 same position, 11:15 same position, 12 o'clock same position. Then body is at rest. Body is not moving. If the body is at same position, then the body is not moving. The body changes the position, then the body is in motion. Got it?
Got it.
If the body is in same position always, if the body is, supposing this one, the body is here at 11, the body is in the same position at 11:05, and the body is in same position at 11:15. That means the body is not moving. The body is at rest. 11 o'clock, same place. 11 after 5 minutes, same place. After 15 minutes, same place. That means the body is not moving. Because the body is in the same place, not changing the position. So if it is not changing the position, it is not moving. Then we call at rest. This is at rest. This is what we say, at rest. But here the body is changing the position. 11 o'clock, this position. After 5 minutes, another position. After 10 minutes, another position. So a body changes its position with respect to time. With respect to time. A body changes its position with respect to time, then it is motion. And if a body does not change position with respect to time, the body is at rest. Okay? This part? So rest means a body does not change position. A body does not change its position with respect to time. Same place. Now also same place. After 5 minutes, same position. After 10 minutes, same position. That means the body is not moving, body is at rest. And if the body is changing the position, now it is in one place. After 5 minutes, another position, another place. After 10 minutes, another place, another position. Then the body is moving. So a body changes its position with respect to time, motion. A body does not change its position with respect to time, that is rest. So there is a motion. Now motion can be of, for instance, how is the motion of the fan blades? Yeah, fan blades. What is the motion? Fan blades. How does it move?
Heat motion.
Huh? What motion? Now, how are they moving? Are they moving from like Calcutta to Mumbai or Delhi to Bombay? How they are moving? They are moving round in the same place, rotating. Rotating round and round. Similarly, the hands of a clock. Today, if it is in Calcutta, tomorrow it won't be in Bombay. Only going round and round. That is rotating. So we can have different kinds of motion. But in this chapter, these are rotating, round, going round and round. Not going from one place to another place in a line. Like it can't go from Calcutta to Mumbai. Yeah, fan blades will not go. It will turn round and round. Rotating means turn round and round. Turn round. Similarly, turning round, rotating. But in this case, we will be considering bodies which move in a line. If a body is here, this is the position A, position 1. Position 1. After some time, it will be in position 2. After some time, it will be in position 3. After some time, it will be in position 4. That means it is moving in a line. It is not turning round, not going round and round. It is moving in a line. So this motion along a line, it is moving in a line, not round and round, not in a circle. It is moving in a line. This is called linear motion. So what we are going to study is linear motion in maths. Linear motion, not turning, not going round and round, not like the earth. But this is linear motion. Calcutta, then Mumbai, then Punjab. Linear motion. This is called linear motion, motion along a line. So this is motion along a line. So all our motion in this chapter, speed, time and distance, all our motion will be linear motion. So whatever we are saying, it is with respect to linear motion. So in this chapter, speed, time, distance, these are linear distance, linear motion, linear distance. Linear motion, linear distance means distance in a line. Linear motion and linear distance. So, first then, before we come to speed, how do you measure a distance? How do you measure the distance? Like weight you measure in kgf, or newtons, force you measure, mass you measure in kilograms. How do you measure a distance?
Kimi or hour?
Kilometer, not hour. Kilometers or meters. Kilometer or meter. Distance. Only distance. Kilometer or meter. Actually it can be, but a centimeter, millimeter, but we are not doing that. Actually it can also be centimeter, millimeter, etc. But these things we don't need now. We will be dealing with only kilometers or meters. And how do you measure time?
Time, hour, minute.
Hours, minutes time, but for our purpose, we will be only considering hour and second. Although, yeah, minute is
Hour.
also there. Hour, hours, minutes, seconds, days, month, year, but for the time being, we will consider hour and minute. So, units of distance, kilometer or meter, although it can be anything. It can be centimeters, it can be millimeters, but for our this chapter, we will consider only kilometer and meter, and units of time, hour or second. Although it can be minute, it can be day, it can be month, but here we will only, here in this chapter, we will have hour and second. Now we come to speed. Speed measures how fast or how slow a body moves. How slow a body moves. How fast it is moving or how slow it is moving. Which moves very fast? Give me one example. Which moves very fast? Something which moves very fast. One example. Huh?
Fan.
Now, fan, I told you, it is round and round. We want linear motion, motion in a line.
Train.
Motion, train, okay. Train. So, and give me something which moves very slow. Something which moves very slow. It moves slowly.
Cycle.
Okay, cycle. That is bicycle. So, when you say train moves fast, train you are saying fast. What does it mean? It means speed is great or high. High speed, great speed. And cycle, when you are saying slow, it means, sorry, slow, not low, slow. It means speed is low, speed is less. So train fast. Fast means speed is high. Speed is more. And when you say train, cycle slow, it means speed is less. So what does speed measure? Speed means how fast or how slow a body moves. A body moving fast, high speed. A body moving slow is a less speed or low speed. Okay, this much?
Okay.
So, speed means how fast or how slow a body moves. A body moving very fast means the speed is very high, and a body moving very slowly means speed is very less. Now, for mathematics, and all our things are linear motion. Don't say fan, don't say wheels. All our motion here will be, all our motions will be linear motion. In this chapter, only linear motion. So all distances will be linear distances. What is the meaning of linear? In a line. In a line. In one line. Not in a circle. Not in a circle, in a line. So all our motions will be in straight line or line, not along all. Not in a circle. We are not dealing with something moving in a circle like a fan. Not moving in a circle, moving in a line, in a straight line or line. All are linear motions. All distances are linear distances. Linear means in a line. Linear means along a line. Along a line. Not in circles. Not moving in circles. not going round and round in a circle, only in a line, it will move. All motions will be linear motions. So, speed was, we define how fast or how slow a body moves or a body travels. Moving, you can also say travels. So how fast or how slow a body travels. So in a number, when you have to say numbers, then we will define speed as distance traveled in 1 unit time. So distance traveled in 1 unit time. That is, it can be how many meters it travels in 1 second, or it can be how many kilometers it travels in 1 hour. How many meters it travels in 1 second, or how many kilometers it travels in 1 hour. Got it? This much?
Got it.
So mathematically we will say speed is equal to distance by time. So speed will have actually a combined unit. 1 unit for distance and 1 unit for time. There are two things, not one thing. Distance by time, two different quantities. Distance will have a different unit, kilometers or meters. Time will have a different unit, second or hour. So, speed, if you have distance in kilometers, if distance is in kilometers, distance traveled 50 kilometers, distance traveled 36 kilometers. And if the time is measured in hour, then the unit of speed will be kilometer per hour. Because numerator distance kilometers, denominator time hours, so kilometers per hour. So it is written either kilometers per hour, or actually the correct way to write is kilometer per this is the correct way of writing kilometers per hour. Sometimes they write like this, kilometer per hour, or sometimes they write only h. But the correct term is this one, kilometers per hour. And if the distance is given in meters, only meters, not in kilometers, and time is given in seconds, then the unit of speed will be distance in meters divided by time in seconds. So it will be meters per second. Per second, we will write as meters per second, or even better, meters per second. Instead of kilometers, we will write meters, and instead of hour, we will write s. So that depends on how your unit is. If the distance happens to be in kilometers, like a train is traveling 60 kilometers and the time is given 4 hours, then kilometers by hour, by time in hours, that will be kilometers per hour. And if the distance is in meters and time is in seconds, like 20 meters in 3 seconds, then meters by seconds, so meters per second. Okay?
Okay.
Unit of numerator, PER per unit of denominator. Unit of numerator, kilometer per PER, and the unit in denominator, hour. Or unit in numerator, meters, and then PER per, then the unit in denominator, second. So per is actually equal to division sign, separating numerator and denominator of a fraction. So, if a train travels 3,000 kilometers in, say, 60 hours, find its speed. So, distance is 3,000 kilometers and time is 60 hours. So, speed will be distance by time equal to 3,000 divided by 60.
Divided by 50.
Now you have to write the unit. First, numerator. Numerator unit is kilometers and
Kimi.
by kilometers, km, divided by the denominator unit is hour. Numerator 3,000 kilometers, denominator 60 is hours. So kilometers divided by hour. First write the units for numerator, then units for denominator. Numerator 3,000 distance. Numerator unit is kilometer. Denominator, the units time is hours. So first numerator, then denominator. So 3,000 will be 0 will cancel. 300 by 6 will be 50. And kilometer per hour, or as I told you, the correct way of writing kilometer per hour. Okay?
Okay.
First write, what is the unit? The unit for numerator, 3,000. The unit is in kilometers. And then denominator, time, the unit, hours. So first numerator, then denominator, first kilometer, then hour. So kilometer per hour. Don't write hour, then kilometer. First numerator, then denominator. First kilometer for numerator, then hour for denominator. First is distance. Distance 3,000. 3,000 kilometers. So first write kilometers. Then by time. Time is 60 hours. Units, hours. So first units for numerator, then units for denominator. So this is the. Now if the question could be given sometimes. A train travels a distance of say 3000 kilometers in 2 days. Or let us say 9,600 kilometers in 2 days. Find speed in kilometer per hour. Right? So distance will be 9600 kilometers and time will be, now 2 days, I want kilometers per hour. So 2 days should be changed to how many hours? 2 days?
2 days.
1 day equal to how many hours? 1 day. 1 day equal to how many hours? 24. So 2 will be 48. So 2 days will be 48 hours. So speed will be given by distance by time, that will be equal to 9600 divided by 48. Again, which unit first? 9600. What is the unit? 9600?
Kilometer.
Kilometer. First numerator. By. Then 48. What is the unit for 48?
48 hour.
First numerator, then denominator. So that will give you 96 by 48 is 2. So 200 kilometer per hour. Right? There's the, or if you want to write in the correct form, it should be, actually the correct international form is, this is actually the correct way of writing. If you want to write in the correct international way, there is the, not slash. The correct international form is this one. So this is how you give the in kilometers per hour. And if you want in meters per second, then cycle travels 500 meters in, or not 500, we will make it say 1500 meters in say 30 minutes. Find speed in meters per second. So distance, keep it in meters, that's no problem. But minutes you have to change to seconds, because meter per second, you want M by S, meters per second. So time will be 30 minutes. 30 minutes you will change to seconds. 30 into 60. 30 multiplied by 60 will be 1800 seconds. 30 minutes multiplied by 60. 30 into 60. 30 into 60. 3 into 6, 18, then 00. So your speed will be 1500. Okay, this became very small. Let us make it 15,000. Otherwise the cycle will be very slow. Okay. So 15,000 divided by 1800. Put it in bracket. In brackets we have put it. Then numerator unit is meters. Denominator unit is seconds. That will give you 0, 0 will cancel with 0, 0. 150 divided by 18. You are getting 150 divided by 18. How much? 2 zeros will cancel. 2 zeros of 1800 and 2 zeros will cancel. So you will get 150 divided by 18 That will give you approximately 8.33. 8.33. Now, meters per second, or as I told you, the correct form of writing is meters space, always put a space, and then write power minus 1. Actually, this is the correct way of writing in higher maths and science. In books, sometimes they write like this, but this is the correct form. M space, put a space, then S for second, and then minus 1 for per. This minus 1 is per, PER, per. Power. So this is how we calculate the speed. Now, and one more question. The more question we'll do next week. The speed may be given, time may be given, that we will do. Convert, say, 72 kilometer per hour into meters per second. So just remember this one, kilometers per hour. If you multiply by 5 by 18, remember this fraction, then it will give you meters per second. And if you are given meters per second, then multiply by not 5 by 18 but 18 by 5. Ulta. Then it will give you kilometers per hour. So remember this 18 by 5 and 5 by 18. 5 by 18 for kilometer per hour to meters per second, and 18 by 5 for meters per second to kilometers per hour. So here we are converting kilometers per hour to meters per second. So this will take 5 by 18. So 72 kilometer per hour will be equal to 72 into 5 by 18. This will be in meters per second. This will be in meters per second. So 18 will go 4 times. 18 into 4, 72. And 4 into 5, 20. So we'll get 20 meters per second. 20 meters per second. This is the way they write in the book. But the correct way of writing is 20 m space S, then power minus 1. This is the correct way of writing. In the book they write like this, m by S. The correct way of writing is 20 m space S power minus 1. That will be the speed in meters per second. Again, if we are given 20 meters per second, multiply by 18 by 5, we'll get kilometers per hour. For instance, convert, say, 30 meters per second to kilometers per hour. So now it is meters per second to kilometers per hour, not 5 by 18, 18 by 5, not 5 by 18, 18 by 5. So 30 meters per second will be equal to 30 into, now it is 18 by 5, not 5 by 18. 18 by 5, that will be equal to 5 will go 6 times. 5 6 are 30. 6 into 18. 6 into 18 will be 108 kilometer per hour. But the correct way of writing should be 108 kilometer space. Always there will be a space between two units. Hour and -1. So this converting. Got this? This part is okay?
Yes.
Say, then don't keep quiet. So this conversion, so I'll be making a summary. So first we said, what is motion? Motion means a body changes its position with respect to time. Changes its position with respect to time. At different times, it will be in different positions. And rest means a body does not change the position with time. Then we said in this chapter, body moves in a line. Body moves along a line. So all our motions are linear motions. Linear motions, and all our distances are linear distances, not round and round like a fan. No circle. It will not move round in a circle. In a straight line it will move. Linear movement and linear distances. Then we said units of distance. Units of distance will be either kilometer or meter. And units of time will be, for us, this should be small, either hour or second. I mean, actually it can be minutes, but we will be converting to hour or second, and kilometers or meters. And speed will, units of speed will be either kilometer per hour or meters per second. So the correct way of writing will be actually meter m space s power -1. Speed will be speed. What does it say? How fast or how slow a body is. How fast or how slow a body moves. So speed here is given by distance travelled in unit time. Distance travelled in unit time. Unit time means 1 hour or 1 second. So speed equal to distance in kilometers travelled in 1 hour. So then you are getting kilometers per hour. Though it should be written as kilometer space hour the correct way of writing. And also speed equal to distance in meters travelled in 1 second This will be meters per second. That is meters space. Always give the space. After giving the space, then minus 1. So this is the formula, distance by time. And for a formula, we will use speed equal to distance by time. So if distance is given in kilometers, or you convert to kilometers, and time you convert to hours, then it will be kilometers per hour. And if the distance is given in meters, or you convert to meters, and the time you convert to seconds, it will be meters per second. This will be the correct unit for speed. And for conversion, we told you for conversion, what I told you, kilometers per hour, if you multiply by 5 by 18, you will get meters per second and small m. And if the reverse happens, if it is meters per second, then you multiply it by ulta 18 by 5,
18 by 5
then you will get kilometers per hour.
kilometer per hour.
And if in any other unit is given like minutes or days, then you convert into hours or convert into seconds according to how it is asked. The way in which it is asked, you can convert. Supposing it is given 30 minutes. 30 minutes you can convert as 30 into 60, 1800 seconds, or 30 by 60, that is 1 by 2 hour. So both are 30. If you multiply by 60, you will get 1800 in seconds, or 30 by 60, 1 by 2 hours, half of 1 hour. So either you can write 1 by 2 hours, that is 0.5 hours, or you can write as 1800 seconds. So both will be there. For instance, it is given a body travels, say, 2 kilometers or 2.5 kilometers in, or let us take it 3.6, right? 3.6 kilometers in, say, 30 minutes. Now it depends on in which unit you want the speed. If you want the speed in meters per second, convert to meters in seconds. Otherwise, convert to hours and kilometers in hours. So one we will be kilometers per hour. So distance is already in kilometers. Sorry. Distance is already in kilometers, so no conversion. Distance 3.6 kilometer. Keep it as it is. Time you want in hours. So time will be 30 minutes equal to 30 by 60. That is 1 by 2 hours or 0.5 hours. Now speed equal to distance by time, that will be equal to 3.6 divided by 0.5. in kilometers per hour. So multiply by 10, that will become 36. And here also multiply by 10, that will become 5. 0.5 into 10 is 5. So 36 by 5 kilometer per hour. That will give you 7. You can check 7.2. 7.2 kilometer per hour. And if you want it in meters per second, then distance will be equal to 3.6 kilometers. If you multiply by 1000, it will be 3600 meters. And time will be equal to 30 minutes, 30 into 60, 1800 seconds. So, now you can say speed is equal to distance by time equal to speed 3600 divided by time 1800. That will give you 2 actually. 0 will cancel. 36 by 18, 2. That will give you 2 meters per second. Got it? And now we will check it. Supposing this 7.2 you convert using the formula. This you got separately. Now we will, supposing you don't calculate this one, from 7.2 I will convert using that formula. So 7.2 kilometer per hour should be equal to 7.2 into 5 by 18 meters per second. Right? So 18 will go 4 times. 18 into 4, 72. So it is 7.2. You first multiply by 5. So 5 into 2, 10. 5 into 2, 10. 1 carried. 5 into 7, 35 plus 1, 36. You are multiplying by 5. 5 into 2, 10. 1 carried. 5 into 7, 35 and 1, 36. So 36.0. That is 36. 36.0 is 36. Divided by 18 meters per second, which is also giving you 2 meters per second. So the same answer you are getting. See, if you convert this one or you calculate separately, you will get the same answer, 2 meters per second. Anyway, you can calculate. Either 7.2 you can convert using this 5 by 18, or you separately kilometers to meters, minutes to seconds, the same answer, 2 meters per second. Method 1, method 2. First way, second way. First method, second method. Answer will be same. Got it? Okay?
Okay.
So that is the first part of time and distance. The second part we will do next Saturday or Sunday. Right?
Okay.
Okay.